With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there is a column of mercury in the middle of a horizontal tube of uniform cross-section, closed at both the ends. Now the pressure of the enclosed air on the either side of the mercury is 75 centimeter of this mercury column. Now when the tube is placed vertical, the length of air below the mercury is 3 by 5 of the length above it. Now if the length of the mercury column is 10 n, we need to find what is the value of n. Now we just represent first of all the two situations. So this is one of the situation. So here we are having mercury, let's say here. So it would be initially it would be just in the middle. So this is our mercury. Here we are having the mercury, okay, in this region, and here we would be having air. So let's say the pressure of here is P naught. Here the pressure is P naught. Let's say the length of the mercury is X and the total length is L. Okay, let's say this is our length L. So what would be this length? So what is the remaining portion? Remaining portion would be L minus X, and it would be distributed equally. So it would be L minus X by 2, and this would again be L minus X divided by 2. Okay, it would be distributed uniformly because the pressure on the both side would be equal. Now what we are doing, we are just making it to be vertical. Okay, now when we will be making it vertical, so there would be weight of mercury which would be acting, okay, in the downward direction. So it would be compressing more from the lower end. That means the lower length would be smaller as compared to the upper length. So let's say this is our mercury. But the mercury, this column would remain same. So initially it was X. So finally it would remain X as X because the mass of this mercury is same. Now what will happen? So initially this was L minus X divided by 2. So for example, if from the middle location, from this location, if it moved a distance of Y, so it would be reduced. This would be reduced by Y. So we can say that L minus X by 2 divide minus Y. And this length would be increased by Y. So it would be L minus X divided by 2 plus Y. Okay. Because if this portion is reduced, that means this would be increased. Why this is reducing? Because this mercury would be compressing here, okay, compressing at this end. So if we just we have been given with the relation with the length here and length here. What is given? That the length below is 3 by 5 of the length above. Now if we just use this relation, so the length below would be equals to L minus X divided by 2. Sorry, length above, this is L minus X by 2 plus Y. This would be equals to, it is given that 5 by 3. It is given as to be 3 by 5th. So it is length below mercury column. Okay, so we are just writing the inverse ratio. So we can just write it to be 3 divided by 5. We take the inverse ratio. So this is above mercury column. It would be 5 by 3 of the length below. L minus X divided by 2 minus 5. Okay. Now if we solve this, then we will be getting, we can just solve this. So we will be getting the value of Y as to be L minus X divided by 8. Okay, this would be the value of our Y. Now again, what we can say, now this would be the temperature. For example, if we just assume the initial temperature here to be T and the mass here to be M, mass of the air to be M, something mass M. Now what will happen? So this would be an isothermal process. So we can say that PV equals to nRT. Now if number of moles is constant, R is constant and T is constant, so we can say that PV equals to constant. Now if we apply this condition into this part, okay, P naught and this part, and we can also take we can apply this part, and we can say that this part also we can apply PV equals to nRT for this part and this part. Okay, so this is corresponding to this part. We just draw this correspond to this part, so it would be in isothermal equilibrium, and this correspond to this part, it would be in isothermal equilibrium. Now we can say that PV equals to nRT. So for the first part, if we just consider, so it would be initially pressure would be P naught, and what is the volume? L minus X divided by 2. This is the length. If we just multiply it by area, so this would be the volume. And we just assume that here the pressure is P naught dash, and here the pressure is P naught double dash. We just put the pressure as like this. So the finally it would be pressure would be equals to P naught double dash, and the volume would be equals to L minus X divided by 2 plus Y. This is the length multiplied by area. Okay, so this area and area would be gone, and we also know the value of Y. Now if you put the value of Y from equation, we say that this is our equation 1 into our equation 2. So we will be getting a relationship between P naught and P naught double dash. So our relationship, P naught and P naught dash. So our P naught would turn out to be, if you put the value, it would be 5 by 4 times of P naught dash, or we can say that our P naught dash would be equals to 4 by 5 of P naught. Now similarly, what we can do, we can just apply the equilibrium condition for, first of all, we have just applied for this and this. Now we can apply it for this and this. So we can say that PV equals to nRT. So initial pressure would be exactly same. and length would be, or volume would be L minus X divided by 2 multiplied by area. Now in the lower portion, pressure is P naught double dash and the length is L minus X divided by 2 minus Y multiplied by the area. This would be the volume. Now again, if you put the value of L from equation 1 into equation 3, so we will be getting a relationship between P naught and P naught double dash. So P naught, this would turn out to be 3 divided by 4 of P naught double dash, or we can say that our P naught double dash would be equals to 4 by 3 of P naught. Now this is the situation. Now if we just draw the FBD for our mercury column, this is our mercury column. So what are the forces which would be acting? From here it would be P naught dash, and from here lower portion it would be P naught double dash. These are the two forces which are acting. And also there would be a mass of the mercury. So we can say that mass would be weight of the mercury. So it would be equals to mg. So in the equilibrium condition, we can say that this is the pressure. If you multiply it by area, it would be force. This is the pressure. If you multiply it by area, it would be the force. So the net downward force is equals to P naught dash A plus mg, and the net upward force is P naught double dash into A. Now P naught dash value we have already calculated, 4 by 5 of P naught multiplied by A plus, how can we write mass? Mass could be written as density into volume. So density into what is the volume? Let's say this length is X. We have already assumed X into A multiplied by G. This would be equals to P naught double dash is 4 by 3 of P naught multiplied by A. So A and A would be cancelled. So we can say that from this expression, we can say that our rho G X value, this would be equals to 4 by 3 minus 4 by 5 times of P naught. So it would be 8 divided by 15 times of P naught. Now what is the value of P naught? It is given as to be length on the either side is 75 centimeter of mercury column. So we know the pressure value. So we can say that our P naught would be equals to rho density of mercury into G into height is 75. Now if we solve this, then our X value would turn out to be 40 centimeter. Now it is given that X is equals to 10 N. This is given as to be 10 N centimeter. So what would be the value of N if we calculate? It would turn out to be 4. So we can say that N value in this problem, N value would be equals to 4. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.